Welcome to the deep dive. Today we're jumping into something really fundamental for modern industry. CNC machines. That's computer numerical control.
Right.
These aren't just, fancy tools. They're kind of the hidden engines driving precision, automation, innovation, really, across so many sectors you touch daily.
Absolutely. From the phone in your pocket to aerospace parts, cars, it's everywhere.
Exactly. So our mission here is to dig into the analysis you've provided, pull out the key insights on the global CNC market, where it is now, where it's heading. We want to help you get up to speed fast on this, crucial industry.
And it's fascinating because looking at this market, it's like a window, right? A window into global industrial trends, how technology is being adopted.
You see the big shifts.
Yeah, you really do. It shows you who's leaning into automation, how different places are positioning themselves for the future of making things.
Okay, let's unpack this global market right out of the gate then. We're talking big manufacturing impact here. What's the overall trajectory look like? Steady climb or something more?
Oh, it's definitely something more dramatic. The global market was valued around, $52.4 billion back in 2021.
Okay.
And it's projected to just explode, really, hitting nearly $134 billion by 2033.
Wow, $134 billion. That's more than double.
More than double, yeah. We're looking at a compound annual growth rate, a CGR, of about 8.13%.
That's strong.
It's very strong. And it tells you this isn't just small steps. It's a really significant global move towards automated production, to advanced manufacturing solutions. It's happening everywhere.
And this is where it gets really interesting, right?
Yeah.
Because the global number is huge, but when you break it down by region, one area just leaps out.
That's right. Asia Pacific, it's the clear leader, not just the biggest market, but also growing the fastest.
Okay.
So in 2021, it was already substantial, like $18.5 billion. But by 2033, it's forecast to surge past $50 billion.
$50 billion, just in APAC.
Just APAC. And its CGR is the highest globally, over 8.8%. Now, what's behind that? Well, a huge part is China.
The industrial hub makes sense.
Exactly. China's market is set to go from about $5.9 billion to $16.5 billion by 2033. That's almost a 9% AGR. Just relentless modernization.
Okay, but you mentioned someone else who's accelerating even faster.
Yeah, this was interesting. India, it's really emerging fast here. Its CAGR is the highest in APAC, something like 9.7%.
Wow.
Growing from maybe $2.5 billion to nearly $7.5 billion by 2033. Probably driven by all those Make in India type initiatives, boosting domestic manufacturing.
Boosting local production.
Exactly. And then you've still got Japan, a major player, growing strongly too, hitting around $7.5 billion, plus South Korea, Australia, Southeast Asia as a whole. They all add up to make APAC just dominant.
Those APAC numbers are really something. Just paints a picture of massive expansion. Okay, let's switch continents. Europe, long history of manufacturing leadership, high-tech stuff. How's Europe fitting into this picture?
Europe's definitely still a major force, particularly as a hub for innovation in this space. Advanced manufacturing is key there.
Right.
So the region started at about $10.7 billion in 2021. It's projected to grow to nearly $26 billion by 2033. Solid growth, a KGR of about 7.65%.
And within Europe, Germany, I assume?
Germany leads the way, yeah. No surprise there. Often called Europe's powerhouse. It's looking to go from just over $2 billion to well over $5 billion by 2033. That's an 8.4% CAGR. Shows their strong industrial roots and, investment in precision engineering.
Still very strong.
Very. And the UK is showing solid growth, too, heading toward almost $4 billion by 2033. France is similar, around $3.9 billion. Italy's also expanding nicely.
Okay.
One point of contrast, though, is Russia. Its growth seems slower, a CGR around 6.2%, noticeably lower than others in Europe.
Interesting. So quite a bit of variation within the continent.
Exactly. Different paces, different levels of investment maybe, but overall, Europe's still a key player driving that sophisticated end of manufacturing.
Okay, now let's head across the Atlantic. North America, often talked about as a more maybe mature market. What's the data actually show about its role, especially compared to that explosive growth in Asia?
North America is. Well, it's a bit of a puzzle in the data, actually.
Oh, how so?
Well, the overall regional market looks set to grow pretty significantly in dollar terms, from about $15 billion in 2021 up to $36 billion by 2033.
Okay, that sounds big.
It is, but, and this is the weird part, the source material gives this remarkably low regional CAGR, like 0.075%.
0.075%. That sounds flat. Almost no growth. How does that square with a jump to $36 billion?
Exactly. It seems totally counterintuitive, especially when you drill down into the individual countries within North America. They look much stronger.
Right. So what's happening in the U.S. or Canada?
Well, the U.S. market, despite that tiny regional average, is projected to grow from $12 billion to over $28 billion by 2033. That's a CAGR of almost 7.4%. Quite healthy.
Okay, that makes more sense.
And Canada's even stronger, relatively speaking, from $1.8 billion heading towards $4.7 billion with an 8.2% CAGR. Mexico is also steady, growing towards $3 billion with a 7.7% CAGR.
So the individual countries are growing fine, but the regional average is tiny. What gives?
It suggests something's maybe pulling down that regional average, perhaps market saturation in older tech segments, or maybe it's more about replacing old machines rather than adding totally new capacity. It's not entirely clear from just this number, but it definitely shows the national markets are still dynamic. They are adopting advanced CNC. It's just a more complex picture than that top-line regional CAGR suggests.
That's a really important distinction. Shows you need to look under the hood sometimes. Okay, so we've hit the big established players. What about regions maybe considered, emerging markets for this kind of advanced tech? Are they catching up?
Oh, absolutely. And fast. That's a really key trend here. Take South America. It's on a strong growth path, expected to more than double from about $3.2 billion to almost $8.6 billion by 2033.
That's a good clip.
Yeah, an 8.4% CAGR. Brazil's the biggest market there, but interestingly, Argentina actually shows an even higher CAGR, almost 9%, suggests pretty rapid industrialization efforts.
Okay, where else?
The Middle East is another one showing really solid growth, projected to nearly triple, actually, from $2.8 billion up to nearly $7.4 billion by 2033. That's an 8.3% CAGR.
And any standouts there?
The UAE is notable, a really strong CGR forecast, almost 9%, likely tied to their push to diversify their economy, beyond just oil. Saudi Arabia is also growing significantly.
Makes sense. And Africa?
Africa too, yeah. Starting from a smaller base, obviously, but gaining real momentum, growing from just under $2 billion to over $5 billion by 2033. South Africa leads that, but Nigeria is also showing steady growth. It really demonstrates that this move towards automation is becoming, well, truly global.
So putting it all together then, all these numbers, regions growing at different speeds, what's the big takeaway? So what's, for someone listening, trying to understand the future of how things get made?
Well, if you connect all those dots, the picture is crystal clear. The CNC machine market is expanding massively globally. It's not just tinkering around the edges.
Right.
It's really being driven by digital transformation, this whole idea of smart manufacturing, and just a fundamental need everywhere for more precision, more efficiency.
Across the board.
Across the board. And you see these interesting contrasts, right? Asia Pacific just dominating in size and speed. Europe and North America, maybe more mature, but still vital innovation hubs integrating the really sophisticated stuff. And then you have these emerging markets, South America, Middle East, Africa, really hitting the accelerator on adoption, putting it all together.
Yeah.
It points to this undeniable global shift, increasing automation, more complex manufacturing, more interconnected systems.
Wow.
A future where how we make things is just much, much more precise and advanced. It's like a fundamental upgrade for global industry.
So the core insight here really is this incredibly widespread, rapidly growing adoption of CNC. It's becoming a cornerstone technology for modern automated production, a huge global shift that's already happening.
Exactly.
And given those growth rates, this embrace of automation, it really makes you think, doesn't it? How's this massive change in manufacturing going to ripple out? What does it mean for supply chains, for the kinds of jobs we'll see in, say, the next 10 years?
Big questions.
Yeah, and maybe think about what other technologies might be playing a similar foundational role, shaping the industrial world in ways we're just starting to figure out.
Definitely. And understanding this kind of specific data-driven analysis like we've done today, it's just so important if you want to grasp the hidden gears, the things really driving the economy and our technological future. Welcome to the deep dive. Okay, let's unpack this. Imagine a world where precision isn't just nice to have, it's non-negotiable. where even a tiny imperfection could be disastrous and everything needs to be perfectly identical, made at lightning speed. That's kind of the unseen force driving so much of modern industry, and it's the world we're stepping into today. We're taking a deep dive into the computer numerical control, or, CNC machine market. This isn't just about manufacturing in isolation.
All right.
It's really a critical, often foundational piece of the whole Industry 4.0 puzzle. So our mission today is to really unpack what's fueling its growth, what challenges companies are facing, and some of the surprising directions it's heading.
What's truly fascinating, I think, is how these machines go beyond just simple mechanics. They're not merely cutting metal. They're fundamentally redefining what's possible. Efficiency, accuracy, even like design freedom. If we zoom out a bit, CNC machines are really the quiet backbone of this whole digital transformation that's sweeping across manufacturing globally. So maybe as we start, what kind of comes to mind for you when you think about machines that can create things with almost zero error?
It's pretty astonishing when you actually stop and think about it. And when we look at what's really powering this market, I mean, one of the biggest drivers is just that relentless demand for absolute precision and efficiency.
Exactly.
Think about medical implants. A single imperfection there could literally be life-threatening.
Yeah, absolutely critical.
Or, in aerospace, a tiny flaw in a turbine blade, that could have catastrophic consequences. It's not just about good enough.
No.
It's about uncompromisable perfection, and that seems to be where CNC machines really make their mark.
Precisely. They drastically cut down on human error because of that computer-controlled accuracy.
Yeah.
And that translates directly into less waste, more streamlined operations,
Right, less waste, faster production.
Yeah, and as industries need more intricate designs, faster turnaround times, these machines really provide that bedrock of precision that modern industries, well, they now completely depend on it.
So beyond just the need for precision parts, what else is sort of fueling this growth at a bigger macro level across different industries?
Well, we're seeing a massive acceleration in industrial automation and the rise of smart factories. This isn't just about replacing manual labor anymore. It's part of that ongoing transformation towards what people call Industry 4.0.
The fourth industrial revolution, essentially?
That's it, where factories are moving beyond simple automation to become truly intelligent, interconnected ecosystems, all driven by data.
And CNC machines seem like they're just perfectly suited for that kind of future.
They really are. Their programmability, their inherent ability to integrate with technologies like the Internet of Things, AI, machine learning, it makes them pivotal. They're key players in this digital evolution. It's no longer just about isolated machines. It's about an intelligent network, all working together.
And it's interesting, it's not just the big traditional heavy industries either, is it? The expansion into diverse end-use sectors and this rise of on-demand custom manufacturing, those seem like huge drivers too.
Definitely.
We're seeing booming demand in fields like aerospace, defense, medical devices, even renewable energy components, all needing complex, often highly customized parts.
And what's truly impressive there is just their sheer versatility.
How so?
Well, CNC machines can handle this incredible array of materials, metals, plastics, composites, even wood sometimes. This ability to produce both high-volume, standardized parts and low-volume, highly customized components, it makes them indispensable.
Right.
Especially in today's, highly specialized and agile production environments. They offer that flexibility.
Okay, so the promise of CNC is clear precision, automation, versatility, but it's surely not without its hurdles. What's the biggest wall companies tend to run into when they try to embrace this tech?
The primary restraint,
Okay.
the one that surfaces again and again, it's the substantial initial investment and the ongoing maintenance costs too.
Right, these aren't cheap machines.
Not at all. Advanced multi-axis CNC machines are incredibly costly to acquire. That upfront investment can be, daunting. Though, it's worth noting, some industry reports suggest that for certain applications, high-volume, high-precision stuff, the ROI, the return on investment, can actually be surprisingly quick.
Really? How quick?
Sometimes within maybe 18 to 24 months. Because you're reducing waste so much, increasing throughput, it can fundamentally change a company's cost structure long term.
Okay, so that high cost is a clear barrier. But maybe could you argue that for certain industries, the sheer quality and consistency they deliver actually makes them, I don't know, a cheaper alternative in the long run compared to older, more error-prone methods?
Oh, absolutely. You definitely can make that argument. The long-term savings from reduced material waste, fewer rejected parts, higher operational uptime that often offsets the initial sticker shock.
So it's a strategic investment, not just a purchase.
Exactly. But to your point, that initial hurdle of getting there, of finding that capital, it remains significant, especially for smaller manufacturers.
And it's not just the cost of the hardware itself, is it? What about the human element?
Ah, yes. This is a critical point. There's a pretty persistent shortage of skilled operators and programmers. While CNC machines automate a great deal, they absolutely require human oversight. You need people for programming complex tasks, optimizing the processes, troubleshooting.
Right, they don't just run themselves entirely.
Not yet, anyway. And in many regions, particularly maybe in developing markets, the technical training infrastructure just isn't robust enough to keep pace with the technology.
So it's like buying a high-performance race car.
Exactly. But not having anyone who really knows how to drive it properly.
Yeah.
And that talent gap, it leads to reduced machine efficiency, sometimes increased errors, and ultimately it can stifle innovation because companies can't fully leverage the investment they've made.
And then there's the challenge of sort of making these modern marvels play nice with older systems. I imagine many manufacturers have infrastructure that's, well, decades old.
Oh, absolutely. Integration is a huge challenge. Compatibility issues, sometimes the absence of standardized communication protocols between old and new machines,
Hmm.
and just the need for significant digital upgrades across the board.
Hmm.
It can make integrating modern CNC machines into existing setups a costly and incredibly time-consuming process.
So those barriers can definitely delay or even derail digitization efforts, especially for smaller operations looking to modernize.
They certainly can.
Okay, so given these challenges, cost, skills, integration, where's the innovation happening? What's exciting is how new developments seem to be already addressing some of these very issues, shaping a more dynamic future for CNC.
Yes, and one really prominent trend is the widespread adoption of multi-axis and hybrid CNC machines. As industries demand even more intricate geometries and faster production cycles, manufacturers are increasingly turning to things like 5-axis and even 6-axis systems. But
And maybe for those picturing a traditional drill press, this is a huge leap, isn't it? This isn't just up, down, left, right.
not at all.
It's about the tool or the workpiece moving simultaneously on multiple rotational axes. That allows for extremely complex parts, impellers, turbine blades, custom medical prosthetics.
Exactly. Things that would be incredibly difficult or impossible otherwise.
And you can often machine them in a single setup, right? Which drastically reduces errors, eliminates having to move the part multiple times, and just significantly cuts production time.
Precisely. And even more innovative are those hybrid machines you mentioned. They combine additive manufacturing, like 3D printing,
Building up material.
with subtractive manufacturing, the traditional cutting and shaping, all on one platform.
Wow.
That offers unmatched flexibility and efficiency. It's especially crucial in sectors like aerospace, mold making, healthcare, where you need that extreme precision, material diversity, and speed.
Okay, so more complex machines. What else?
Another major development is the integration of the Internet of Things, IoT, and predictive maintenance.
Right, making the machines smarter.
Exactly. Modern CNC machines are now being outfitted with smart sensors. They monitor real-time machine performance, things like vibration, temperature, even tool wear.
And these capabilities enable what's called predictive maintenance.
That's the key. It means issues can often be detected and resolved before they cause costly downtime.
So it's about using data to see a problem coming.
Yes, leveraging data to foresee a problem, like maybe an unusual vibration pattern indicating a bearing is about to fail, before it becomes a catastrophic failure that stops the whole production line.
That must save a lot of money and headaches.
Absolutely. It not only extends the machine's life, but also significantly reduces operational disruptions and optimizes how you use the asset. It's a shift from reactive fixes to proactive prevention.
That makes sense. And lastly, you mentioned customization earlier. It feels like we're witnessing a huge surge in that, and on-demand manufacturing, largely driven by, well, us consumers demanding personalized product.
That's a huge factor.
Mhm.
Whether it's, say, a custom car part, a bespoke piece of jewelry, or a tailored medical implant, CNC machines are enabling manufacturers to respond with incredible agility. Their ability to efficiently handle low volume, high mix production, lots of different things in small quantities, is truly revolutionizing how companies approach prototyping and small batch production,
So this trend is helping businesses become more customer-centric, more adaptive.
and ultimately more competitive than ever before.
So wrapping this up, what does this all mean for you, our listener? We've explored the incredible precision and efficiency that CNC machines bring to the table. We've seen how they're pretty much essential for modern industrial automation and their surprising versatility in custom manufacturing.
Hmm.
We've also talked through the hurdles, those high initial costs, the critical need for skilled operators, and the complexities of integrating them with older systems. But maybe the most exciting part is seeing how the future is already tackling these challenges. With multi-axis hybrid machines, smart sensors enabling predictive maintenance, and that surge in on-demand customization really changing how products get made.
And if we zoom out again to the bigger picture, the CNC machine market isn't just growing, it's rapidly evolving. It's moving toward a more intelligent, more flexible, and fundamentally a more autonomous future. So this raises, I think, an important question for you to consider. As manufacturing becomes increasingly automated and personalized, through technologies like CNC, what new opportunities or maybe even entirely new industries do you foresee emerging? Things we haven't even perhaps imagined yet.
Yeah, that's a great thought to leave things on. We hope this deep dive has given you a bit of a shortcut to being well informed about a fascinating and really foundational aspect of our modern world. Thanks for joining us for this deep dive into the world of CNC machines.